Okay, we're in section 22, which is going to be the radical equations. Now we're going to have equations where there's going to be a radical involved. All right. We will talk about this. This is going to be a very short lecture again. We typically try to make the lectures incredibly short. Then we go to examples. Right. The examples are going to illustrate the points being made in lecture, though. All right. So we'll go through that and then we'll get to the examples. But let's just do that. It's a very short lecture, by the way. All right. So let me go to that. I'm going to go to another share with you. I'm going to share a whiteboard with you now. All right, so it's solving a radical equation, and let's go through this. Very short lecture, by the way. All right, we'll talk about it. Now, granted, when I say it's a short lecture, I'm not going to say you understand everything that's being presented to you. Hopefully, we do examples, things become more clear. All right, so the first thing it says, if two real numbers are equal. That's a big if, by the way. It says then the same powers of those equal numbers are equal. That is, if A equals B, then A to the n equals B to the n. All right. This can be useful in solving equations involving radicals. So we're going to deal with equations involving radicals, but it may also be misleading. All right. We'll talk about why it's misleading, but right now it can lead to misleading answers. And the reason it can be misleading answer, it could produce an answer where it doesn't satisfy the original condition. And the original condition is basically a root equation. All right. So my claim over here to do these problems that you're going to be getting now, you're going to be given a radical equation. What does it mean? You're going to be given an equation now where there's going to be a radical in it. This is an equation with a radical in it. All right. We're going to talk about the method, and the method's going to be incredibly simple to do if you can follow what we're stating. And we'll go through many examples. All right. So I'm given a radical equation over here. And the radical equation is over here. Now, chances are it's going to be a simple problem. We don't want to start with difficult ones. It'll be a simple problem. My goal here, though, is to talk about a method that's going to work with the problems you're being presented with. The first step is, one, make sure you have equation. We do, with the radical in it. The very first step, though, is to isolate the radical. Now, what does that mean? To get the radical on one side. All right. So let me write that down for you. Number one, first step, isolate a radical. What does that mean? Radical alone on one side. That's done. Every single problem I do, that'll be step number one. I have an equation. I want to isolate a radical. Your next step is to raise both sides of the equation to the index of the radical. I'll write that down for you. Raise both sides of equation to the index of the radical. All right, let's put that down. Raise both sides to the index of the radical. Someone says, what's the index? The index is the number sitting in over here. Someone says, oh, there's no number there. Well, you should know this is the only radical that doesn't have a number there. What's the number? It's a square root. The number's 2. So I'm going to raise both sides to the power 2. And we get something pretty simple. What do we get? Well, the left side, when you square it, is just x. The right side, when you square it, is 25. So I got my answer. Now, could my answer be wrong? Of course it could. That's why we want to check it. Where's the check? In the original. What's the original? This is the original. What's the square root of 25? It's 5. Does 5 equal 5? Of course it does. All right, let's take a look at another example. I'm going to pull on the side. Yes, I know there's work there. Whoops. And we'll do this one. All right. Don't be discouraged, though. A lot of people say, I can't do it, can't do it, I can't do it. All right. So my first step is what? Isolate a radical. Well, you know what? Whoever wrote the problem, this radical is isolated. There's only one radical, and he's on the left side. He's isolated. What's my next step? Well, my next step is to raise both sides to the index on the radical. And what is that index? In this case, square root problem, it's a 2. Now, what's nice about this? The left side's super simple to do. When I square that, I get x plus 1. The right side's more complicated. And a lot of students make mistakes with this. What does it mean? X minus 1 times x minus 1. What does it give me? X squared minus 2x plus 1. All right, now someone says you made the problem far worse than it ever was. And it's true, it's gotten more complicated. Here's the problem though. Although it's more complicated, I think I know how to solve this. It's quadratic. How do you solve a quadratic? Zero product rule. I need to get a 0 now. I'm no longer thinking about radical equations. I'm thinking about my past now. And what do you get over here? On the left side, you get 0. On the right side, you get x squared minus 3x. And that's about it. What's zero product rule say? I have a 0, but I don't have the product. So I need to factor it. GCF is x minus 3. So now I know the answers to this equation. The answer to this equation is going to be x equals 0 or x equals 3, right? Now I realize what a lot of students want to do. They want to box it and leave it. I don't want to do that. I want to check it. Where does the check go? Back in the original. What was the original? This was the original. I'm going to check this. I want to see if it works. I'm going to check this. I'm going to see if it works. Which one's easier to check? Probably 0. Let's check that. We're going to do a check. If you plug in 0 on the left, you would get the square root of 1. If you plug 0 on the right, you would get minus 1. I hope you realize the square root of 1 is 1, and that does not equal minus 1. So this did not check. I'm not going to put that as an answer. Let's check 3. What do you get on the left side? You get the square root of 4. Again, 3 plus 1 is 4. But again, the right side, 3 minus 1, which is 2. Well, the square root of 4 is 2, and 2 does equal 2. So this is the correct answer. That is going to be our method. Isolate the radical, raise both sides of the equation to the index of the radical. That's isolated, by the way. And then solve the resulting equation. Also, at the very end of it, check to make sure your answers are correct. If they're not, cross them out. All right. I want to point out this answer is over here. And again, we check it, only 3 work there. Again, please check. Again, short lecture followed by a much lengthier examples with problems to follow that you could work on your own too. Thank you.